Today we're going to be talking about integrals. Now, what is an integral? An integral is kind of like the opposite of a derivative. It's how you go. So say a derivative, how you go from y to y prime to y double prime and so on. An integral is how you go from y double prime to y prime back to y. And we'll do this in the basic undefined way and also the defined way to where you get your actual numbers. So we know that a derivative, say we have a function y is equal to 3x squared plus 2. We know that the derivative of this function is equal to 6x, and that's just it. We know that the double derivative is equal to 6, and that the third derivative is equal to 0. Well, so how could we, going the derivative way, we want to go backwards. That's how we do an integral. Let's look at this on a graph real quick. So we know that, say we have y, say let's just use y is equal to x squared. We have our function like this. We know that y prime is equal to 2x and its graph is just a straight line. We know that y double prime is equal to 2. Its graph is a straight horizontal line. Let me make that a little bit bigger. So we have that, and then we know that y triple prime is just equal to 0. So it doesn't even have a graph. But say we want to understand, how do we go? So an integral is the idea of everything under the curve. The area under the curve is the integral. So everything, say this is 1, 2, 3, everything between point 0 and point 3 under the curve, this, doing the integral, gets us this area. And it gives us these values. It's how we go back to the first derivative. The sign we use to use this is a big old S. So we would say the integral from 0 to 3 of y double prime with respect to x is equal to the first derivative from 0 to 3. But we'll get into that later. But basically, then say we're looking at the first derivative, everything under the area from 1, 2, and 3 is how we go back to this graph from everything from the area of 1, 2, 3. That is how we go backwards. So it's just giving you the older thing. And you'll use that in calculus and in physics a lot. So for physics, it's something like, say, the basic kinematic functions, we have x of t is normally your position. The first derivative is your velocity. The first derivative of position with respect to time is equal to velocity. And that's velocity. And then if you do the second derivative of position, or you do the first derivative of velocity, you get a of t, which is acceleration. So the second derivative of position with respect to time, blah, 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 all the way down, is equal to acceleration. Or the first derivative of velocity. And those are the basic things that you would need for physics right there. But those are, again, with respect to time. Say position is something of x is equal to 2t plus 2. Well, when you do the first derivative, you get velocity will be equal to just 2. And then the acceleration would just be equal to 0 in that case. But that's the physics idea behind it. But in physics, you might have to look at a graph and say you had the velocity graph looks like this. You have from 1, 2, 3, and it comes down. To find the area under the curve, that would give you your integral. You would find what is the position the disposition of the object. You look at 1, 2, 3, and you would see that it's traveled some distance, y, say we're going to say it goes up to 4. Well, the area under the curve, this is a triangle. So the area is equal to 1/2 length times width. So it's equal to 1/2 times 4 times 3, and that gives you 6. So you would know that this traveled 6 meters. Say this was the velocity graph, and you took the integral of it. That is how you would find the integral, is just by using the area under the curve. And then you would get that it traveled 6 meters. But so let's actually understand how to calculate an integral. So like I said, our integral is this big old sign. And say we have some function of x. And again, f of x is equal to y in this case, with respect to x. That is the basic way of writing an integral. And so say we're going to say f of x is equal to 3x plus 2. So if we rewrite this, we have the undefined integral. So when you have an undefined integral, it means you don't have limits. Limits are where I was saying that over here, the limit would be from 0 to 3. That would be our limits that we would have plugged in for this integral. But right now, we're just looking at an undefined integral, which does not have these limits. So say we had the integral of 3x plus 2 with respect to x, and it is undefined. So the way we do an integral is we take 3x plus 2, and what we want to do is remember how the derivative was taking down the exponent and then adding 1, and then subtracting 1 from the exponent. So this is kind of like the opposite. You're going to go backwards in steps. So technically this is x to the first. What we want to do is add to the exponent. And then this new exponent after we add, we're going to divide by that new number. So then for this constant, we're basically just going to add a variable to it because we don't have a variable yet. So you're basically just now multiplying it on. But so this would give us 3 over 2 x squared plus 2x. And we can confirm this because say we took the derivative of this function, say we did 3 over 2 times x squared plus 2x, if we subtract 1, or if we move the exponent down and multiply by 2, and then subtract 1, and then take this 1, and let's separate these so I can make it look a little better. Say we brought down and multiplied by 1, and then subtracted 1, well, the 2's would cancel out, and then this x would go to 0, and we would go back to 3x. We go back to 3x plus 2. And that would be how you would just confirm how that does that. But so let's say we wanted to take the integral of 3 over 2 x squared plus 2x. So 3 over 2 x squared plus 2x. We take the undefined integral of that. Well, we would get, let's go down and evaluate it. We have 3 over 2 times x squared plus 2x. So we would add 1 and then divide it down here. So it would now be 2 divided by 3. And then we would have this variable over here. We were going to add 1 and then divide by 2. So this integral would give us 3 over 6 x cubed plus 2 over 2 x squared, which is the same thing as 1/2 x cubed plus x squared. Now, for an undefined integral, I didn't fully write all these correctly because technically an undefined variable can always have some random constant. So you always want to remember to put plus c for an undefined integral. For an undefined integral, always, and I mean always, plus c. So this would technically be 3 over 2x squared plus 2x plus c. This would be 1/2 x cubed plus x squared plus c. Because technically, if you took the derivative, so 3x over 2 plus c, because technically, if you took the derivative of this function right here, say we took the derivative of this, well, we would get 3 over 2x squared plus 2x, and that constant would just go to 0. So you always have to add in your constant in it. Now, how would we find the actual numerical value of an integral? Well, that's where we would use an integral, a defined integral. So a defined integral. And this back up here was an undefined integral. So going back down to the defined integral, we have, say, let's look at our thing that I was using from 0 to 3. So we're just going to use 0 to 3 for this. So we have the limits from, we start at 0 and we're ending at 3, of 3x plus 2 with respect to x. Saying dx means that we're integrating the x term in this function. So say we're doing it now from 0 to 3. Well, again, we just figured it out that the integral of this is 3 over 2 x squared plus 2x. And normally we would put plus c, but because this is a defined integral, we can actually find the numerical value of this. So we're saying it's this function, so it creates some graph. So remember, we're going backwards in time. We're going backwards in derivative. We now have some function, we have some graph, and it's not a straight line here, but it's some graph that we're going to take the area under the curve of to be able to get our numerical answer. So you normally write it in brackets like this, and we say that it's from 0 to 3. So the way you do this now is you just plug in the upper limit for all of the x values, and then you subtract the lower limit when it's plugged into all the values. So we would say that this is equal to 3 over 2 times 3 squared plus 2 times 3, all of that minus 3 over 2, 0 squared plus 2 times 0. And when we solve all of this, we'll get 3 over 2 times 9 plus 6 minus 0. And then when you solve this down, we get that's equal to 27 over 2 plus 6. And you just do your basic arithmetic, and we'll get 39 over 2, or about 19 and 1/2. And that would be how you would solve the defined integral. So thank you very much and have a great day.